Hello everyone, and welcome to join the AR Design Augmented Reality Immersive Design Method workshop from the ASCD 2022. And my name is Yang Song, a practice-based PhD student from the University of Liverpool. So I will be with you today together during our workshop. The workshop gonna be around like 4 hours. So first of all, thank you for choosing my workshop. And I didn't expect it that we have so many participants, I think, which is 44, I think. It might be the biggest workshop for the ASCII this year, which is great. And ideally, I'd like to do that in person, but unfortunately, because the COVID pandemic, we have to do that online. But this is all right because our AR method is remote. So you can achieve that on your mobile phone. But if you have the like a Microsoft HoloLens or any other AR headset devices, it can support you to achieve like more immersive inputs like hand gesture recognition or like interactive input or the 3D environment scanning. But we can start with our mobile devices. So today gonna be a very basic introduction for AR. So it can be your first time try to design something in AR. And in the future, if you have any chance to come to UK, so you can contact me and I will let you to try the Microsoft HoloLens in the lab. Before we start, can I like ask you to turn on camera for a second if you don't mind? I just wanna like take a photo with you together to keep this as a memory. Hey. Hey, there will be more people get. Because we have so many participants, I will just skip the introduction because that gonna cost a lot of time. Okay, I'm gonna turn on the camera of my mobile phone. Okay, okay. Okay, 3, 2, 1. Yay, thank you. May I ask a question like, do you have any experiments of using Rhino or Grasshopper? If you have tried them, you can send a message on the chat. If you have tried Rhino or Grasshopper or any AR devices, okay, right, I got that. Yeah. If you don't have any experience about the Grasshopper, it's all right because today I'm gonna show you is the very basic things on Grasshopper, and I also share the file with you. So if you don't understand how to develop the process, you can just follow my logic. Okay, yeah. Yeah, if you don't have any experiments, don't be worried. You can just follow that. Okay, I'm gonna share my screen again. So let me introduce the workshop schedule. Today, the workshop gonna be divided into 6 parts. The first is the introduction of which is my research introduction, so I can give you a basic background of what I'm doing. And the second will be the AR introduction. After that, we're gonna have a small break. And the third is the basic AR function tutorial. So you're gonna try to do some small demo on the mobile phone through the Photogram plugin and Grasshopper. After that, we're gonna have a small break for you to try that. And the fourth will be the parametric design method tutorial, which I'm gonna show you a basic method of me to generate one of this break column. And you can play with my parameter sliders on the user interface. And also you can create your own design algorithms. And you can replace my basic break into your own geometry to make like more fancy shapes or design. And after that, we will have a lunch break. So you can use that time to develop your personal design or customize the design algorithms. After the lunch break, we're gonna have a Q&A session, which you can show your design to me, or if you have any questions, you can ask me during that time. And the other thing that you need to remember is after the workshop, you're going to submit two things. One is the customized design file, which could be a Rhino or a Grasshopper file. And the second is the AR recording video, which is a screen recording from your mobile phone that's showing you like changing the parameter sliders on the UI to show the design modification. And also you can hold your mobile phone to walk around around your design in the AI environment and something like that. So I have already shared the Google Drive link for you to upload. If you don't have that, I will copy and paste the link in our group chat now. Okay, I will copy and paste that. Yeah. So for example, this is our file share folder. So you can right click here to create a new folder with your full name. And just upload your file into your folder. So I can check that clearly. And good, for now we have like two. Okay, we have more folders. Yeah, I think someone has put another person's folder in that. So please make sure remove your folder from others' folders. So I can see you under this folder, under the participants outcome. Good. Because this outcome will be related to your workshop certifications, so you'd better upload your file before tomorrow, I think. Okay, so I will give a brief introduction about myself and my PhD research project in the University of Liverpool, because our workshop is a part of my preliminary research outcome. So my name's Yang Song, and I got the master's degree of architecture from the Bartlett UCL, and I start to do the cross-disciplinary research related to architecture design and augmented reality technology. So now I'm a practice-based PhD student from the research group in Kaba, the Center of Architecture and Visual Arts, University of Liverpool. So I continue my previous research direction and try to add the robotic fabrication technology into the AR-assisted workflow to explore the interaction between human, robots, and data and their mutual relationship through the immersive design to fabrication process. So this research project is supervised by Professor Richard, who is the chair in architecture and visual arts. He is interested in digital database and immersive media, VR and AR technologies. And this research is also supervised by Asterius, who is the director of architecture school. And his research includes the parametric design, generative design, VR, AR, robotics, and digital fabrication. So according to my research process, the whole project will be divided into 4 main parts, including the AR-assisted design, AR-assisted simulation, AR-assisted assembly, and the AR-assisted human-robots collaborative fabrication. And what we're going to try will be the first phase of my research. So the first phase of my research project is the AI immersive design. So we use AR-assisted user interface where you could interact with parametric settings on your smart devices screen and preview the design outcomes on set as 3D holograms in the immersive design input and preview method. So the data will transform from your screen-based input interactions to the design software through AI environment. This is the method we're going to try today. And another method for me to do that is using the AR headset, the Microsoft HoloLens, because it will give you like more possibility to achieve the hand gesture interactions and more complex interactive inputs. So for example, for this diagram, I'm using my hand gesture to draw a curve on the ground. So after scanning the environment, after reading my hand gesture, the curve will be snapped on the ground. And after the curve is determined, we can extrude the curve into a surface. So you can see here, and also on the surface, we have several control points, which is virtual control point in the AI environment. So actually, you can use your hand to grab the virtual control point in AI environment to change that and preview that in real time. So after the shape of the wall is determined, you can use the HoloLens AR UI to generate the break. So you can play with the break density and the break size, also the break rotation to finish your design. And the second phase will be the AR-assisted simulation for real-time structure stability simulation. And the physical performance will be shown as holographic animation on set before the structure is built. So the user could preview it first and also figure out where is the fragile parts that need to be modified or the structure need adhesive or not. So for example, on this case, you will see on the left corner, it is falling down. So you need to modify your mesh a little bit in the AI environment to make it stable. So below is the working flow in Grasshopper that I'm using the PhysicX physical structural stability simulation to simulate the physical performance. So you know, if the structure is falling down, you need to adjust your design shape or use adhesive to glue them together. So the third phase of my research is the AR-assisted robotic fabrication. And we create for programming the robots by hand gesture and also operate like the trajectory planning, pick and place, and also optical avoidance. So this method will give architects and designer possibility to achieve the complex shape digital fabrication by themselves. Because before, for now, if you want to achieve like advanced fabrication method or like digital robotic fabrication method, you need help from the industrial engineer or someone who knows computer science technology. Otherwise, you don't know how to operate that. But like using my method, you can also operate the robots in the AI environment just by really simple visual guidance. So this AR-assisted robotic fabrication is a more safer and more effective method to operate robots through the AI environment by hand gesture command. And all the computer science programming technique has been pre-coding in Grasshopper. The user just need to point out the preparation area and also the target location in AR interface. So they can operate the robotic fabrication layer by layer or brick by brick, depends on their assembly sequence. And in this way, the robotic fabrication workflow will not require specific computer science knowledge and skilled programming workers. Even unskilled architecture students can easily manipulate this process. And the last phase is the AR-assisted human-robot collaboration method. So we create a target location recognition system by the Kinect sensor RGBD camera to scan, to recognize and analyze the brick location, which need to be picked in real time. Because I want use this method on set, so the brick will be like everywhere on set. And I put the Kinect sensor, plug the Kinect sensor to the robots, similarly like give the robots eyes to see where the brick is. So we don't need any fixed feeding location to feed the brick one by one. Instead of that, the robot can see where the brick is and they're just gonna pick them automatically. So this is a method for the robot to read and for the sensor to scan and try to extrude the geometry of the brick. So after that, we also create a human-robot interactive collaboration method for the adhesive application. So human worker can see the brick, which is in operation in the white outline hologram, and also the area that need the adhesive in red. So they just need to feed the adhesive in the red area and activate the robot to put the brick on. So actually, the red area is the overlapping area that's calculated by the computer. So this method can avoid material waste and also can keep the on-set environment clean. Because there's some methods now that automatically apply the adhesive on all the surface of the brick, which is very messy and waste material. So I think this kind of method can give a better solution for applying the adhesive, because I think human labor, they are better deal with this kind of issue than the robotic or than automated adhesive application. So these are the outcome from AR immersive design to simulation to human-robot collaborative fabrication process. So you can see it is very clean, and the adhesive just be applied in the overlapping area, so nothing else in on the rest surface. So it's very clean. And I did a break column and also break wall. So I do publish like several journal and conference papers in each step of my research. The first is the literature review, which I published in the automation in construction. And the second is my framework concept explanation, which I published in Cadre 2021. And the third is the AR-assisted robotic operation method, which I published in Sigradi 2021. And the other is the physical framework test in the CDRF 2022. And I have another paper which describes the AR immersive design in our ASCD this year. And we are preparing more paper about the physical simulation in the future. Okay, so that is the my research, the basic introduction of my research. So actually, you know, what we're gonna do today is part of my research. So I'm gonna give a basic introduction about the AR technology. So let's have a look about some case studies which are done by AR technology in different functions. They are the holographic brickwork, which is the AR-assisted hologram assembly done by the All-Brick Company and UTAS. The second will be the steampunk pavilion, AR-assisted steam-bent hardwood structure, which is done by Hologram and also Sumiham Design. The third is the build with Spark, holographic fabrication, fabricate complex 3D geometries, which is done by RMIT in Australia. So the first one, the holographic brickwork, using the augmented reality with the physical space. And holograms seek to facilitate the construction of complex design. For example, the parametric design that require a series of measurements and verifications and specific pairs through digital instruction that are virtually projected onto the workspace, detecting a step-by-step guidance for the bricklayer during the construction process. And the hologram expected that augmented reality will gradually eliminate the drawing on construction set, avoiding the errors and increasing the speed and precision of the construction process. So they present a method for generating holographic construction information from parametric models. And the holographic models replace 2D drawings and templates with contextual, shared, and interactive design information in AI environment. So we can watch a video. Okay.
University of Tasmania have been implementing hologram in workshops scenarios, so building complex brick structures, building complex timber structures, and working with it in a fabrication environment. UTAS ran a workshop and invited Colin and his team at Allbrick to come and try out the headset on some of the tricky geometry that they were producing in the university. So we heard from the team at UTAS that they wanted to put the brickies to the test on this complex fabrication project, so we went down to see what they'd been up to.
There isn't a single brick on there that lines up to anything. Every brick is different. This would take you like 2 weeks.
Yeah.
For one guy, and a lot of that would have to be, made up. Do you know what I mean? You're not going to get it exactly like this would be.
UTAS provided a design model, and Colin used hologram to turn that into a holographic instruction set. This lets Colin see the outline and precise placement of every single brick in the wall. Aside from using hologram as an instruction set, Colin was also able to use it to train his apprentices.
So that's all the bricks, right? Yep. So see how you are here. That one's good. Yep. This one here shows it's got to come round. So just treat that like you do your string line all the way around. Mm-hmm. So hit that back. It took us 2 brick layers, and it took us took 2 brick layers, about 6.5 hours.
The really exciting thing about this project is that now Colin and his team can approach architects and enable them to design more complex things, knowing that he has the capability to build them. I was surprised by the accuracy and the fidelity to the digital model that Colin and his team were able to achieve. I'm really looking forward to seeing how Colin can work with architects to develop more complex structures that are even more challenging than this one and build them at a larger scale in permanent projects.
I once seen a program on John Lennon, you know, and he reckons every song that he made, he used to get scared that I'm going to stop now because I'll never make anything better than that, you know. That's how I'm thinking, it's time to stop. I'm nervous that I can't make nothing better.
And the second case is the steampunk pavilion. And this pavilion is constructed from the steam bent hardwood using the primitive hand tools, augmented with the precision of intelligent holographic guidance. So the installation was built in the 5th edition of Tallinn Architecture Biennale ATB 2019 in Estonia. So they are interested in approaches to making that hybridized analog construction with the precision and flexibility of the digital models. So by rendering digital models as holographic overlays directly within the construction environment, the fabricator can use their own experiments to produce highly complex objects entirely by following this holographic guidance using relative primitive analog tools. So the timber elements in this structure are fabricated following the difficult process of steam bending, and each wood strip is backed, steamed, and bent over an adaptable models framework using the holographic models as a reference to desired results.
Steampunk is a pavilion built from steam-bent hardwood timber for the 2019 Tallinn Architecture Biennale. When we won the competition to build the pavilion, we weren't really even sure if our proposal could be built. And this is because we'd never really steam-bent anything from timber before. It seemed like it was a pretty common feeling shared between everybody who'd seen the design.
When I saw the entries, one proposal, I had scary dreams that this will be chosen, and I didn't even imagine that this can be done.
Using Hologram, we developed a set of holographic applications that allowed a team of volunteers to follow interactive holographic guides in order to accurately fabricate each one of the unique parts of our structure.
Oh my god. Here, it's up in here. I think it's almost 2 meters. Yeah.
Do you think we're going to be able to bend it over that?
Let's try. Wow, this is not going to be easy.
Rather than working from drawings, a holographic model showed exactly where formwork needed to be placed in order to bend any of the curving timber strips in the design. We added a holographic overlay to a metal bar bender in order to augment this cheap analog tool with the precision of digital models. A simple holographic interface was used to select and display the correct bend angles for each steel bracket in the structure. These brackets were then located precisely in space using a holographic model overlaid directly on the construction site. This model provided a reference for what the pavilion should look like at any stage during construction, and we were surprised to find that small errors, either in the fabrication of parts or how these parts had been installed, were always able to be identified and corrected. We, like everyone else, were expecting to have to change or simplify our design in order for it to be built. But we were surprised to find that by changing how we build, we're able to so significantly affect how and what we can design. By combining precise digital models with adaptable human craftsmanship, we see exciting opportunities for traditional material practices to evolve. We're looking forward to seeing how other designers and architects can take Fologram's tools and begin to realize even more ambitious proposals, previously just the stuff of crazy dreams.
Yeah, and the third case study is a build with Spark, which is a workshop done by Hologram. So they do the workshop in person because they need the AR headset to achieve that. So we can watch a video like what they are doing for that.
Australia has these incredible paperbark trees that get their name from the layers of thin bark that are kind of like this big stack of paper. And paperbark has an amazing variation in color and texture, and it's a completely renewable resource that you can find just about everywhere. And I walk past these paperbark trees on my way to the office every single day, and then when I get into the office, there's even one right outside my window. And it's got me wondering whether we could build something with the bark. Here's how that turned out. So finding paperbark in Melbourne is pretty easy. You just check out a street on Google Street View, and if there's a melaleuca there, which is the scientific name for a paperbark tree, then you can go drop by and take a bit of material. It's really great being able to find all of the trees because then we only need to collect a small amount of material from each one, and that prevents us harming any of the trees by collecting too much bark. And every single piece of bark is unique, and this is one reason why I would normally make such a crappy construction material. But in our case, this variation can also be an advantage. Different species and thicknesses of bark can be used to make a stiff but fragile curving frame that can then be covered with layers of laminated bark that become much stronger and start to hold their form. For strength, whatever we design to be built out of paperbark needs to consist of a lot of areas of tight double curvature. This makes it pretty hard to design structures from paperbark just on the fly, making it up as you go, because you really need a guide while you're working, or everything just turns into a floppy mess. Luckily, these curving forms are nice and easy to model in design software like Rhino, and together with architecture students from RMIT, we came up with a set of parts that fit together to form a bark wall. We used this digital model of the parts viewed in augmented reality as the guide that we needed for assembling bark into frames that were simultaneously clad to form nice stiff structures that could be transported into our office, where they're now a partition wall.
Okay, so, yep. Here, clads from there to here.
Yeah.
So it goes sweep.
Yeah.
And then it goes a bit more. And then it tucks over and it donuts in here.
It's really hard to see what you're doing when you're only working from the wireframe in augmented reality, so we also used a depth camera on the HoloLens to scan the bark while we're assembling it and show how closely the bark matched our digital design. The different colors and textures of the bark can be used to create a palette that doesn't exist in the digital model, which is just a flat grey surface, but is instead made up by the fabrication team on the fly. And so these sculptures capture both qualities of analog craft and the smooth curvature of the digital modeling software that was used to design them. This exact same technique of building curving structures from irregular materials in augmented reality could be applied to other found materials that are often overlooked, like river stones or other kind of granite material just collected from the bush, or branches from trees that have maybe fallen down and are irregular, unprocessed timber, or even material like bamboo in other parts of the world. It could also work with conventional materials like strips of steel, and this might be a way to scale these processes up. Or, because the only tools required are the battery-powered HoloLens, some adhesive and some staples, continuing this project might involve taking the HoloLens to the bush and working directly with the the bark on site rather than transporting the bark into our workshop and making a huge mess. And it would be amazing to randomly discover a strange bark shelter on a remote bushwalk somewhere, and this is the experience that we'd love to create.
Yeah, so we saw like three case studies which is done by Hologram in the AI environment because they are using Microsoft HoloLens. So they have like more advanced input method or interactive method, includes like real-time scanning or hand gesture inputs or something that we cannot do on our mobile phone. But today we're gonna just try a very basic interaction about the AR input, like the screen-based input for the AR immersive design. And if you are interested in the AR, you can check the website, which is, I'm gonna show the website here, which is called Hologram. I will copy this link into our chat. So this is a Hologram website. They will publish like several things that they've done using the augmented reality. And it is also a great tool for you to achieve the AR design and also AR fabrication through Rhino and Grasshopper, which is very architectural friendly. So you don't need any other software to help you just for this plugin. And they have a community which you can ask questions, and you can also see what kind of project they have achieved recently. And also you can try to see what kind of paper that they have published recently. So if you are more interested in AR, you can try to use this website for you to develop your knowledge in the AR area. So yes, this is my paper about the immersive design. Okay, I think
Australia has the...
Yeah, and also here, I will suggest you another website which is related to the digital fabrication area. So this is a searching database. It is called CUMINCD. I can copy the link to you in the group chat. So this research database is the paper collection from Ascadi, Cadria, Icadi, Sigradi, and CD Futures. So you can actually like input maybe augmented reality and search all the papers related to augmented reality. Or if you are interested in other digital fabrication area, for example, like the robotic fabrication or 3D printing or artificial intelligence, you can just search the keywords here. It is very nice and very fresh for the results. So I'm gonna copy and paste this database link to you in the group chat. So if you want to do maybe, I'm not sure, like if you are now a bachelor and you want to continue your master, you can search something here, like in the digital fabrication area, what kind of things you are interested. And if you are a master now, you want to do a PhD research, you can also use this website to find something in the same area that had already been done by others, try to find the research gap, and you can create your own contribution based on their research. So the use of augmented reality technology has increased recently, and due to the equipment update and new mature technology development. For architectural design, especially in digital fabrication projects, more designers began to interact with the AI method to achieve the visualization in process. To help the unskilled laborers for holographic on-set previewing and instruction trainings, experimental and practice-based studies in AR for architectural digital fabrication. So the use of AR function in architectural design has been classified in like three following parts. The first will be the AR 3D holographic instruction, which you can assembly and also fabricate according to that. And the second is the AR data sharing, includes the AR immersive design and AR cyber physical construction. And the third part is the AR for human-computer interactions, which include the AR UI for robotic operation and programming by demonstration through AR. So I think now it is a great opportunity to discuss the topic of AR in architecture and design and digital fabrication. Also, the immersive technology, for example, like virtual reality and augmented reality, they are pretty hot topic this year. So it's not too late for you to start the research or get interested in them. I think I finished the introduction about my research and a basic introduction about the technology and some case studies. So we can have a 10 minutes break. So make sure that using the break time, you need to install the Photogram plugin in Grasshopper and also on your mobile devices. And if you have any question for installing the software or plugins, you can just ask me. So we're gonna come back around 11. So see you in 10 minutes. Okay, so welcome back. We're gonna do the basic AR function tutorial in this session. So this is the workflow development environment. So we are using Rhino and Grasshopper for the design algorithm setting up and also the design environment. And we are using the Hologram plugin to connect the design environment with the to the AI environment. So the Hologram is a platform for designing and making in mixed reality. It can achieve the mixed reality live stream and saved models preview on the smartphones, tablets, and also AR headset, including the Microsoft HoloLens 1, 2, iOS, and Android mobile devices. So on the laptop client, the Hologram is installed in Rhino and Grasshopper to steam and interact with the models, work with the gestures and markers, and also model and control the data flow from the design software to AI environment. So on the mobile device client, the Hologram app provides the AR interface tablets and the hologram for user to view and interact with in Rhino model and Grasshopper parameters, and also tracking gestures and QR code and also ROC markers. So apart from the HoloLens, other mobile devices that need to support ARKit and AR Core for iOS and Android devices. So the Hologram is a tool that links design software and AR environments, provide the users with the ability to interact with the model through the AR. So
Hologram connects mixed reality devices to CAD modeling software. You can use Hologram to build and share your own interactive experiences, all within the tools that you'd normally use.
Hologram is going to bring us into a new era of design.
When you realise that what you're looking at is the thing that you're about to make, it almost becomes immediately intuitive.
It's totally life-changing.
So to go from a bloody sketch and then with your 3D modelling on the computer and then to produce this is just mind-boggling.
It's been exciting to see people realise ideas and designs which they thought would otherwise be impossible in minutes with Hologram.
Drawings have always been seen as integral to the profession of architecture, but while they're incredibly good at describing two-dimensional geometries, they aren't good at describing non-planar geometries. Some of the models that we've been creating simply would not be possible to build in any other means.
So if you install the Hologram successfully, you will see a panel of the Hologram through your Rhino user interface on the right-hand side. If you cannot see that panel, just tap in the command line Hologram and activate that. So when you activate the Hologram panel, you will see a purple button here. So press the button, it will generate a QR code for you. So you can use your Hologram app to scan this QR code to connect the laptop with your mobile phone together. So one thing that you need to remember is that your laptop and mobile devices, they should be in the same Wi-Fi IP address. So if the connection is successful, you can see a small logo here, which describes what kind of devices you have already connected. And it is also supports the multiple devices. So maybe if you have like 2 mobile phones, or if you have an AR headset or tablet or iPad, you can press that to connect one by one. And this is the user interface for Hologram in Grasshopper. So they have like several functions for you to play with, which include the flow, the sync, track, and also utilities. We're gonna try some of them today, but if you wanna know all of them, like what kind of function they can do, what kind of possibility they can apply, if they can be applied, you can check the link below. They have a full description about that. I will copy this link to our group chat as well. So actually on that link, you can see they have a full description about each function in Grasshopper, like what is the input, what is the output, what kind of thing they can do. So you can read carefully about that. Yes, you can re-put the QR code. You can just press this button. They will generate a QR code for you, so you can scan through your mobile app one by one. So they're gonna have a basic introduction and about each function's input and output, what they're gonna do. And today we're gonna try thinking objects, thinking parameters, thinking text, and interactive objects and tracking devices. So I'm gonna stop sharing my PowerPoint. I'm gonna show you in Rhino. Okay, this is the Rhino. And if you installed Hologram successfully, you will see here we have a Hologram panel. And this is the button for us to generate the QR code. So if you press that, there will be a QR code, and you can use a mobile phone to scan the QR code. Also, if you didn't see any thing happen on this panel, just tap here, hologram, to activate that. Maybe the first time you need to activate that first, and then you will see the panel here. And also you can see a panel on the top, which is called hologram, for you to activate the panel and also create QR code. So this is a great function. Maybe some of you like thinking, if I put the virtual model in the physical world, where they gonna be located, or how can they be recognized? So this QR code is a method that for you to scan this QR code in the AR environment to locate your model. So to do that, click on the create QR code. They will ask you to input the origin. So normally we set the origin as 000. And they will ask you the x-axis, just the x-axis as same as Rhino, and a y-axis. So actually now you can see a QR code. And you can also choose the paper size to print QR code. And also here is a folder for you to save the QR code. So you can click the folder here and save the QR code. Maybe I just gonna save the QR code on the desktop and press enter. So the QR code will be generated and saved here. and you can print this QR code to scan that and locate the 000 point. So normally I print this QR code and put that on the ground to scan through the mobile devices. So actually your mobile phone knows that where is 000. So you can preview your digital model accurately. So this is the function of the hologram QR code for you to locate your models.
I'm sorry, can you repeat from the set origin a bit?
Okay, yeah. So it is a function on hologram. Here is a create QR code. So press that, and it asks you to set the QR code origin. You can use your mouse to set the origin as 000 here, the corner here. If you want to be accurate, you can activate the grid snap. So it will actually catch the 000 automatically. So press your mouse here. It means you set the origin. And this is asks you to set the x-axis. So just follow the Rhino x-axis. Press the mouse, and it will ask you the y-axis. Press the mouse, and here is the code. So for this input, you can set the paper size for printing, and this is the folder for you to save the QR code. So you can select anywhere you're gonna save and press enter on your keyboard. So now the QR code is generated. So you can print that and place it on the ground. When you scan the QR code through your mobile devices, it will locate to the 000 point. Is that clear?
What if the create QR code is not showing up? I've connected hologram, but it's not giving me the create QR code on top.
You don't need to connect the hologram. The create QR code is in Rhino. Can you find the panel here?
I did not find it. Though I connected to the phone, and it's on the program right now.
Make sure you're using the same Wi-Fi on both the phone and the laptop.
Yes, I'm using both.
What kind of Wi-Fi you are using? Are you using the uni Wi-Fi, university Wi-Fi, or any public Wi-Fi?
No, I'm at home.
At home, it happens sometimes. It's because of your Wi-Fi settings. So if that's not gonna happen, you can use your mobile data for the hotspots to connect your laptop and mobile phone.
Okay, thank you.
Okay. Yeah, so this is the method for you to locate your model in the physical world. Yes, please, do you have any question?
Yes, I can't find the icon of hologram on the Rhino.
You can, if you can't find, just tap hologram.
I did, yes, but I can't. Yes, I did already this step, and I connected my phone with the device, but the icon hologram and QR code that are showing on the successor rows after below command are not available on my Rhino.
Which version of Rhino are you using?
It's Rhino 7 Corporate.
Rhino 7, it should be work. You can just check the panel settings if the hologram is not activated.
Okay, but command when I type command hologram, it give me hologram QR, hologram update check, and when I press on hologram QR, it get me set QR code origin. That the step that you was explaining but there is no icon for the hologram is popping up with the menus and other icons.
Yeah, when you tap hologram, just press the first, not the hologram QR or update check, just this one.
Okay.
Yeah, and it should be show up here, like something here. So press this one is for the right hand side panel. Press that one is for you to create the QR code.
Okay, sorry, I will activate. Where? Where from?
Hmm?
Where do I press? Sorry.
Press that.
Yes, where to bring this from?
Just tap hologram.
Okay.
Yeah. If you cannot see that, which means you didn't install the software successfully, you can try to install that again. If you tap hologram, nothing happens. You need to install the software again.
No, I feel like the software is already installed because I connected with my phone, and my phone is giving me like a hexagonal mesh for everything that it's in my surround. That's why I knew that hologram is installed, because I scanned the QR code that it was generated from my PC using the camera. Yes, using this. Yes.
You can see that QR code.
Yes. Yes.
Okay. Okay. So that should be fine. You don't need to do that. This is a method.
Icon.
Yeah, this is the method that I introduced for you to locate physical words with digital model, but we don't need this function for now, for today. In the future, if you want to do any more accurate operations, you can use this kind of function. I'm just give a basic like introduction about the plugin.
Okay, thank you.
So if you activate your Grasshopper, you will see the hologram somewhere here. So these are the functions in the hologram in Grasshopper. So I'm gonna show you the first basic function is thinking objects. Like how can we input the object into the AI environment? So for example, I'm gonna set a mesh. So you can choose here mesh. There is a mesh sphere. Press the mesh sphere here. It will ask you to input the base. We're going to use the default base as 000, and the radius, we're going to set the radius to 30. To set that, just double click anywhere you want, just double click and input 30. It will create a slider for you. So connect this slider to R. So you can play with the slider. Actually, you can see there is a ball. And how can you change this ball into the AI environment? You need a basic function from hologram. So just press hologram, and here is a think object. Connect the think object with your mesh. So actually now it is in the AI environment. So I'm gonna show you how can you connect your mobile device to check this model in AR devices. I'm gonna share my mobile phone screen. So 1 second. Yeah. So now you can see my mobile phone screen. If you already installed the hologram, you will see a hologram here. Someone, can you mute? I will mute everyone. So you will see a photogram app here. Just click this photogram app. And it asks you for you to scan the QR code. So for generating the QR code, press here, scan the QR code. So now you can see a mesh. The mesh means that your mobile phone is reading the environment. So you can tap on your mobile phone screen to set where you're gonna put this ball. So I'm gonna just put that ball on my desk. So for now, you can see my ball is in the AI environment.
Could you please repeat?
Mm-hmm.
Could you please repeat the way you connected the sphere to the hologram?
Okay, so when you create a sphere here, find the function in photogram in Grasshopper. There is a function called sync object here. If you press photogram, choose the sync object, connect the output from M to the photogram. And you will see your ball here. And I want to introduce something that you can play with this photogram function. When you right-click that, right-click, so you can see there is a function for you to play with the color. So actually, you can change the color of your sphere. And also, you can select a texture. So I'm gonna maybe just randomly choose a photo. So now you can see your sphere is with some interesting texture. If you don't want that, just right-click, choose the texture again to delete the texture. So you can use that kind of function to play with the color, the texture, and also you can change the transparent here. And there will be 3 more functions. Movable means if you click the move ball, you can actually move your ball from the mobile screen. So for now, you can see I'm moving that from my mobile screen. This is a movable. So actually, you can see on Rhino, my ball is moving. So this is a function called movable. If you choose clickable, which means that the ball can be clicked. So this is a function like if you have a series of balls, when you click one ball, you can get the index number of this ball. So I will do that later. So for now, you just need to know you can click this ball by choose the click ball. You can move that ball by choose the movable. And also you can grab the ball. But this one asks you to need to use the AR headset. We cannot do that through our mobile devices. So you can play with the first two for click and move. And also you can change the color, change the transparency, or add the texture for more fancy setting up. So this is the first function that I'm gonna show you, which is the sync object. So please remember, for hologram, it only reads mesh. So you need to create something from the mesh. If you have some other geometry, just use a function called graph mesh. Oh, sorry. Called the mesh graph here to change something into mesh. So I will introduce that later. But for now, you need to remember that the hologram read mesh. Okay, do you have any questions?
Yes.
Yeah, please.
I'm sorry, everything worked, but the hologram, like scanning app, it's in your case, it's not showing the hexagons. In my case, it's not like it's always showing the hexagons. It's not showing the sphere alone. It's still showing the rectangle for the like QR code, and it's not really like attracting to one plane. Even though I'm trying to scan my environment, it's only like hexagons upon hexagons.
So you can only see hexagons, but you cannot see your sphere.
No, I can see it. I can see my sphere, and I can see the QR, like the rectangle parameter of the QR code. It's the problem is that it's not like it's not as clean as your screen. It's always showing me the hexagons like overlapping each other as if it's not really scanned. Yeah.
Yeah, you can press the screen to select the surface because the hexagon is scanning your surface. So if you want to put your sphere on the desk, you can just like press on your mobile screen to press the desk. So the hexagon will disappear, which means that your sphere is snapped on the desk.
Yeah, I'm gonna try to. Thank you.
Okay. So this is the first function that we're gonna try. And I will introduce a second function for you to try in the AI environment. So I'm gonna stop the mobile sharing. Okay, the second one will be the thinking parameters. So we're gonna use the mesh sphere as well. So press here to create a mesh sphere, double click anywhere to input 30 as our radius. And also you can select the UV. The UV means the deviation of the UV line. So I'm gonna put the UV as 10 and 10. So you can see 10U and 10V maybe is too less. So if you think 10 is less, you can double click here to change the maximum maybe to 50. Let's change it to 50. The more of the UV setting, the more accurate for the sphere. So this is the way for you to create a sphere. And also we're gonna show the UV line. So how can we achieve that? In the mesh, here is a function called mesh edges. Just press that, connect the mesh with mesh edges. And use hologram. Think object. Show the sphere first. And think object. Show the edge. So I'm gonna set the sphere as white color, and I'm gonna set the edge as red color. So actually, in the AI environment, you can see a red sphere. You can see a white sphere with red UV line. And how to do the thinking parameters? There is a function called think parameters. Here, press that, and you will see some hologram logo on the interactive sliders. So you can activate the radius, activate the U and V.
I have one question.
Yeah, please.
Is the recording available for us to make those later?
Yeah. We have the recordings. So I think Oscar is gonna share you the recording after today's workshop.
Okay, then we will give you this after the workshop, right?
Yeah. You have like 1 day or 2 days more to develop your own system.
Sorry?
Mm-hmm.
It's about that most of the students don't know about Grasshopper.
Yeah, I think I shared the Grasshopper file. So if you cannot follow me step by step, you can just see the file. I think I shared the file link via email yesterday. So
Yes, because it was very short notice, you know, it was like yesterday, and maybe
Yeah.
they was able to understand everything. And when you use the interface of Grasshopper and you plug the whatever the steps to work on the sphere and those trial that he was explaining like few minutes ago, that was probably they couldn't understand what was the part of the grasshopper and how to do these steps. Later they need to understand this when they watch the video, or maybe they will have the recorded explaining video.
Yes. The recording video will send to you after today's workshop. I think Oscar will send you that. But just try to follow my logic. You can watch this file. So you don't need to follow me step by step. I'm just explain the logic of this system, because Grasshopper is the only way that we can achieve AR. So if you are not familiar with Grasshopper, you cannot achieve that in AR. But the thing I explained today is very, very, very basic things in Grasshopper. So if you cannot follow me step by step, you can just use my file to watch that. So I think the file I share is called basic AR operations. So for you to do that is just download that file, it is here, and drag this file to the Grasshopper. So you can actually see I have already created all the things for you to play with. So you don't need to create that by yourself. You just need to follow my logic. I just explain like what is what. So if you want to play with the sync object, you can just select the file here, click.
Yes, that's more easy. Yes,
Yes.
that will be more easy for everyone.
Yeah, I
Thank
understand.
you.
That's why I create this file for you. So you don't need to follow me step by step, but you need to know the logic, like what is controlling what. And this is the basic introduction. So you just need to get familiar with the function. And for your own design, I will explain more clearly. So there will be 1 or 2 parameters for you to play with. So don't be worried about that. You don't need to develop anything in Grasshopper. You just need to play with it. Yeah, so okay, for here, what I'm trying to say, yes, I'm trying to show you how can you input this kind of interactive sliders on your mobile device. So I'm gonna connect my mobile device again. Yeah, I understand like most of you don't know Grasshopper, but don't worry. So now you can see my mobile screen. I will snap it on the top. So press the photogram app. scan the QR code. And yes, your sphere is here. So how can you achieve this kind of interactive parameters? You just need to click. There is a button on your AR device here on the left-hand side. So click this button, you will see 3 sliders. Yeah. So just play with the sliders. You can see actually your sphere is growing. Right. It is very easy. And also you can change the UV line.
Excuse me, how did you connect the QR code again?
Just
as you connected it the first time?
Yeah, to connect the QR code.
Okay, I connected the QR code, but when I'm using the folder you gave us right now, you asked us to drag it to the grasshopper. It's not showing up on the hologram on the phone. What's showing up is the initial sphere, the one I made.
1 second. You mean you drag the file here, you cannot see the file? Or
yes.
It won't be happened. If you drag the file here, you will see the file because I'm not.
Yes, I saw the file over here, but I did not see it on the hologram, like you're seeing it on the phone.
On the phone, because
yes.
the file is in Grasshopper.
Yes.
Yeah.
Okay, but now you reconnected it to the phone.
Yeah.
Yeah, I'm not. It's not showing up on the phone right now. What's showing up is the initial sphere. Not the folder you gave us.
You need to stop your hologram. Like here, just swipe that up and open that again.
Oh, okay. Thank you.
Yeah, so this is a way for you to play with the interactive parameters.
Yeah, it's very fun.
Yeah. You can also try, like, if you have any Grasshopper knowledge, you can also try several other geometries like the mesh box or mesh plane or mesh sphere or some other things you create. It will be pretty easy for you to achieve in the AR environment. And also, this is a method for you to show something that you create up on the physical world for the digital model. So just remember, like, the function here in hologram, which is called sync parameters, it will give you the possibility to take this kind of slider to the hologram app. So you don't need to change that on Grasshopper. You can change that on your app. So for the free version of your hologram app, you can only add 3 parameters. If you want to add more parameters, you need to pay for the plugin and also pay the app. But I think 3 parameters, they are enough for our workshop. Yeah, so this is a method for thinking objects and also thinking the parameters. The next function that I'm gonna show you is, okay, I'll check. Is the thinking text. So how can we show the text in the AI environment? So first of all, we're gonna make a sphere. So press the mesh sphere. We're gonna set the radius as 10 maybe. And we need to sync this, we need to show this sphere in AI environment. So we choose the function in Hologram, sync object to show the sphere. And we're gonna, if we wanna create a text, they will ask you for a reference point. So we're gonna use the sphere as a reference point. So we go to the parameters, and there will be a function called mesh. Choose the mesh. And there will be another function called mesh area, which means they will get the central point of the mesh. Because now we have the mesh as a sphere, we need the central point as the reference. So now we got the reference and we got the sphere. The last thing is to input the text. So we choose Hologram. There is a function called sync text. The T means text input. The P means reference point. So we're going to connect the C with the P, which means our reference point is the central point of the sphere. And the S means the text size. So we can double click at the empty area, input 50, which means the size of the text. And if you want to input the text, go to the parameters. Here is a function called panel. Click the panel, double click to input the text that you want to show. I'm gonna say SKD AR plus design workshop. So connect the text with the function here. So actually you can see there is a Ask the AR design workshop, but I think it's too big, so I'm gonna reduce the size of the text to 20. So we can play with something more interesting, because remember before I introduced like the sphere can be moved. So we can right click here, choose that as movable. So actually in the AI environment, you can move the sphere anywhere you want, and the text will follow the sphere. So I'm gonna show you on my mobile device now. I will connect my mobile device. Remember to restart your Hologram app anytime when you want to do a new thing, so it won't show you previous design. So now I'm connecting my mobile device again. Okay, this is my mobile screen. I'm gonna run the stop the hologram, run it again. Snap the QR code, put my sphere on the desk. So for now, you can see there is a sphere and my text. Because I choose the sphere as movable, so for now you can move the sphere through your mobile device. Maybe I will move that here, so you will see the text is following that. So this is a method for you to input some like instruction or some description text. If you don't want to see the sphere, you can just reduce the radius. So actually the text will show by itself. So this is the way for you to show text. So for now, we have already know how to see geometry, how to see text. And the next thing I want to show is that the hologram gives you some function for you to track your own device. So how to do that? In the hologram function, there is a function called connected devices. So press that. And there will be another function called track device. Press that. Connect the D with D. So actually you can see on the Rhino file, your mobile phone is in the design software. So it will change your physical mobile phone into the design environment. So actually you can real-time track your devices. So to get more thing interesting, you can get the plane of your mobile phone, you can get the mesh of your mobile phone, and also you can get the central point of your mobile phone. So to do that, there is a point in the parameter settings. Press the point to connect the T with the point. So this point will be the central point of your mobile phone. And there is another function called plane. Press the plane, connect the plane with the T, and actually, if you zoom up, you can see your mobile phone plane. So which is the x-axis, y-axis. So you can use this method to set some points through your mobile phone. So actually, it is recording your location. So you can put your mobile phone maybe here and to set some connected point to create a curve or something. So it will give you some interactive input methods. You can know hologram have this kind of function, but it is much more difficult than what we're gonna learn today. So I won't introduce that function to you, but you can know this is a method for you to input something with your mobile phone from the physical world into the digital design world. Yeah, and I think you can play with my the code that I share with you. I think I share like more than I explained today. So if you open my file, they will be here, and you can select all of them, press the group on your mouse, choose the enable, so you can activate this script to play with that. This is showing objects, and disable them to see the second one, thinking parameters, and also thinking text, and also interactive objects. The interactive, I'm gonna show you the interactive objects. So if you enable them, you will see a series of balls. So this function gives you a possibility that if you press one ball, you can actually get the index number of that ball. So this means that you are pressing the ball number 2. So this is ball number 0, 1, 2, 3, 4, 5. Like that is 10, and that is 15. So this is a function that I use for the robotic fabrication. For example, if I have a brake tower or have a brake column, I can just press the brake which I want to do. So the robots know the index of the brick. So the robot's gonna help me to pick and place that brick to the correct location. So that would be like many interesting functions that you can create or play with in the hologram. So just try my file from Grasshopper. You can play with that for a little bit. So I'm gonna give you maybe 20 minutes for you to play with. I will be online, so if you have any questions, just ask me. I'm gonna see you again at 12:10. So at 12:10, I'm gonna explain the design algorithm of the brick column. So for now, you have 20 minutes to play with the AR interface through your mobile device by using the file that I shared to you. If you have any questions, just give me a shout. I will be online.
Yes, I have a question. I'm sorry for asking a lot, but I enabled the files and they're still not showing up on Grasshopper, and also they're not showing up on the hologram.
You mean the hologram? You cannot find the hologram in Grasshopper and Rhino?
Yes, no, I found the hologram on Grasshopper and Rhino, and I connected the phone, but right now I can't. But right now I'm not being able to. I enabled the file you gave us. Okay, and now I can't find the file on the Grasshopper. Okay, and I can't find it also on the hologram to edit it.
You can't find it in Grasshopper. Okay, 1 second. So when you open the Grasshopper, it will be shown like that. And if you download my file, it is here. Have you already downloaded that?
Yes, exactly. I made these steps.
Yes, and drag this file to Grasshopper.
Yes,
and
I did this, and then I enabled the files.
Yeah, you can see them, and you enable that. There's no Sapphire, or
no, there's no.
There's no Sapphire.
No. This is what I'm passing to.
Let me check. I'm gonna stop sharing my screen. Can you share your screen to me?
Yes, sure. I can't share my screen. You did not disable the.
Okay, now I can share.
Okay, can you see my screen now?
It's loading. 1 second. Yes, I can see.
Is the Grasshopper shown?
I think you locked them. Press the unlock.
Okay. How can I unlock?
Press your screw, the screw mouse. Yes, unlock them. Yes.
Okay. Thank you.
Yeah, I think you enable all of them. So try to disable all of them and enable them one by one.
Okay. I have one more question. It is the same idea about connecting from this icon once we're connecting these. Okay. Thank you.
Yeah. Yeah, I saw someone send a message in the chat that the hologram command is not appearing. I'm not sure the hologram command you mean is in Rhino or in Grasshopper. Yeah, Mohammed, do you have any questions? I will be online, so if you have any questions, just give me a shout, and I will see you again in 10 minutes. Okay, so I'm back. Hopefully you have already played with the basic function of the basic AR in Hologram. And for the next session, I'm gonna introduce the design logic for me to create the break column. So I'm gonna use the second break column as an example to show you how can I generate this structure and how can I do the interactive modification through the user interface. So if you have already downloaded the file that I provide for you, let me check. It is here called design algorithm plus ARUI. So if you download that, just press and drag that into the Grasshopper. So you will see in Rhino, you can see a column structure. In Grasshopper, you can see all the shape generation methods. So this is the file that you're gonna upload to the Google Drive. So don't be worried, you don't need to achieve all of them. The only thing for you to do is to play with some interactive parameters. Like here, the column height, so you can change the height of the column. And I set like a middle zoom scale, so you can change the scale of the column. The column rotation, so you can actually rotate the column. I have, because I use this function, sync parameters, which I just introduced to you in the previous session. So I just turn 3 parameters on because we are using the free version, so we can only achieve 3 parameters in our mobile device. So I turn the column height, the middle zoom scale, and also the column rotation. You can try to activate something else if you want to play with. So just play with this button, choose 3 of them, and play with that on your mobile device. And if you want to do more fancy things, you can change something here at the end, the thinking parameters. For now, it is white. So you can change that to any color you want, or you can select the texture. If you want to make a wood column, you can download some wood texture. If you want the brick column, you can download some brick texture or some concrete texture. Select that and apply the texture on your own structure. So if you don't have any Grasshopper skill, you can play with the preview color and texture, and also play with the parameter sliders. But I'm gonna explain the step. I'm gonna explain the process step by step. So you just need to listen and follow my logic. Like, how can I create this kind of structure? It will be easy. Just take it easy. Just follow the logic. This is for the no skill user for the Grasshopper. If you have any skill in using Grasshopper, I will describe that later. So you can change something. You can create some fancy shape instead of my basic brick to input that geometry into the column generation. And also you can select different type of the brick or different type of the geometry to apply different color for them. So I'm gonna explain that step by step. You just need to follow my logic. I will copy my outcome into this random file. So this is a break column. How can we achieve that in a parametric design method? So first, you need to find a middle point. So I will use the 0, 0, 0 as a middle point. This is the first step in the parametric logic. And the next, you're gonna create a sphere around this point, which describe the radius of the column. And next, you're gonna duplicate this point to the sky, which is the height of your column. So this is the height of your column. And you're gonna divide your column according to the break height. For me, for my break height, the height of my break is 20 millimeters. So I will divide this line with the length of 20 millimeters. So you will see several layers. And after that, just duplicate this curve, this circle curve onto that point. So you will generate a column like that. So I will do that step by step. So first, there is a function. There's a function in vector, which is called construct point. So we press that. Automatically, it will give us a 0, 0, 0 point. So this is our reference point for the column. And then we need to get the plane of the column. So we use a XY plane for the reference plane. And next, we're gonna draw a circle. So we use a function in the curve, which is called circle. So connect this point to P, which means you define the middle point of the circle as the 0, 0, 0, and input R as the radius. So I'm gonna set the radius as maybe 200. That's too much. So you can double click and re-input any numbers. So I'm gonna set that as 100. So right click here to rename that. I'm gonna name it as column radius. So this is the radius of my column. And next, I'm gonna move this point to the sky. So the function of move this point is a function in transform called move. So we click this function. This is asking you for the geometry that you want to move. So just connect this point to the geometry. And you need to tell them the direction and how long you're going to move. So there is a function here in the vector called amplitude. So press that. It will ask you a vector direction and a length. So for the direction, we're going to choose the z direction. And in vector, we have a z direction. Connect the z direction to the v, And we're gonna say I want my break column be 640 millimeters long, so millimeters tall. So I'm gonna connect the 640 to the A and connect the weight to the T. So now you can see the point is in the sky. So right click here. I'm gonna name it as column height, which means that you can play with the height to change the you can play with the parameter to change the height of your column. So you remember the next step, I'm gonna draw a line between these 2 points and divide the line based on the height of the break. So how to draw the line? There is a function in the curve called line. So press the line. It asks you for a start point and an end point. So the start point will be this point. We connect the point to A. The end point will be that point. So we connect the B to the G. And here we got a curve. Now here we got a line. And we're gonna use a deviation function here called divide length, which means it will divide the curve by the length. So we choose this function. The curve we divide is this curve, so we connect the L to the C. Here they ask for the deviation, so which is the height of the break. So let's double click here, input 20, because I use 20 millimeter as the height of the break. So you can here rename it as break height. So now you can see the line is already divided. And we need to set the plane based on this point. So we go to the vector, choose XY plane, connect the XY plane with P. So now we have a plane. So for now, we can duplicate all the circles along the point. So how to do that? There is a function in transform called orient, which means that the G means the geometry that you want to duplicate. The A means the reference plane of that geometry. The B means the target plane of that geometry. So we connect the circle to the geometry because this is the geometry that we want to duplicate. And the reference point, reference plane of the circle will be the 0, 0, 0 plane. So we connect the 0, 0 plane to A. The target plane will be this 33 planes. So we connect them here. So for now, you can see we have already duplicated all the curves, all the circles. And let me show my pen. So for now, you can see from the structure I did, there is a small curvature on the set line, but now for us it is straight. So we need a method to scale the curve down to make it as that, to create a small curve. So how to do that? There is a function in transform which is called scale. It will ask you to, the G means what kind of geometry you're gonna scale. They are these circles, so we connect the G to the G. And here, they ask the center, which means where is the reference point for you to scale. we're gonna connect this plane to the C, and they will ask you the factor, which means how much you're gonna scale. For the default, it is 0.5, which means it's scaled down in half size. So this is not what we want. We want it from maybe 1 to 0.5 and back to 1. So we need to set something here. The scale gonna be from 1 to 0.5 and back to 1. So it can make the curvature like that. So how can we do that? We're gonna use a method which is called in a set which is called list length. So it will calculate how many points we have. So we connect the point here. As it output, it shows us we have 33 points, which means that we have 33 circles. So we need divide the 33. There is a function in math called deviation. So we divide the 33 with 2. So the result will be 16.5, but we cannot use any float. We need to change that into integers. So there is an integer function in the parameters here. We connect the integer to the output. So it will change the 16.5 to 17, which means that from 0 to 17, this is half of our column. And we need to create another half from 17 to 33. So how can we do that? There is a function in math. We need a subtraction. This is the total number we have, which is 33. We connect it to the A, and we connect the result of the first half to the B. So the result will be 16, will be the rest. And we need another function called domain, which means we're going to set a domain from 1 to 0.5. So to create a domain, there is a function in the math called construct domain. So we're going to set 0.1 and 0.5, which is the maximum and the minimum scale. So we can rename that as top zoom scale, and rename that as middle zoom scale. So this is a domain, and we need to divide this domain into 17 parts, so it can create a series from 1 to 0.5. So there is a function called divide domain. So we're gonna divide this domain into 17 parts. So actually you can see the outcomes. It is from 1 to 0.5. Yeah, I know this part is very complicated, but you just need to follow the logic to see how to generate the shape. You don't need to understand each step. So for now, we need to extract the outcome from this domain deviation. Similarly, we're gonna do the same things for the upper part. So we're gonna Control C and Control V, copy and paste that again, and connect the C with the result of 16. Because they are duplicated, so we can use the same parameter sliders. So because the upper part will be from 0.5 to 1, so we connect the 0.5 first, connect the 1 second. We can delete that to use the same parametric sliders. So it will be our scaling input. So we use a function called merge, M-E-R-G-E, merge, to connect them together. Select the S, select the E. So actually, you can see the output from this small panel. It will show the results from 0 to from 1 to 0.5 and back to 1. So this is the scale that we want. And we can connect the scale to the F. So for now, you can actually see we have already created the curvature. To see that clearly, I'm gonna blend all of the previous functions so we can see that more clearly. Just select all of them, press your group, and choose Disable Preview, so you can only see that. And we're gonna extract the parameters to one set, so we can play with that in the AI environment later. So for now, you can see if you choose the middle zoom scale, actually the column is changing. Right, so for the better shape, I'm gonna set the as to 0.7. And for the next step, we're gonna create some plane on the circle to transform the break shape to our column. So how to do that? There is a function in vector. Function in curve, which is called horizontal frames. So choose that, connect it with G. Because we haven't set the number, so the default number is 10. You can change that number whatever you want. So for me, because I have like 3 breaks for each layer, so I'm gonna set the n as 3. So for now, you can see we have 3 breaks in each layer. So if you play with that, you can achieve like 4 breaks or 5 breaks, 6, whatever. So I'm just gonna set 3 for now. And because my geometry, you can see here, we have a slightly rotation, right? So it is exactly rotating from the middle point like that. But now what we are designing is very straight. There's no rotation. So the next logic of me to generate this shape, we're gonna rotate each circle in a certain degree. So how can we do that? We're gonna use a function in the transform, which is called rotate. So this will ask you to rotate the geometry that you want and the degree you're gonna set, and also the plane. So we're gonna set the geometry as the frame because we want to rotate the frame. And for now, you need to right-click at the A to change this one into degrees. So we can, for example, if I choose 90 degrees, You can see it is rotating, right? From 0 to 90. But they are all rotating together, which we don't want that. We just want it rotate step by step, like one by one. So we need to create a series. So let me create that. You can double click to set the total rotation. So for me, I'm gonna set it as 90. And let me rename it as column rotation. So which means this is the rotation. And we're gonna divide this rotation to layers because we have 33 layers. 33 layers for each step, they're gonna rotate 90 total. So we use a function in math, which is called deviation. We're gonna divide 90 degree with 33 layers because we got the 33 from here, so we connect the L to the B, which means in each layer, we only need to rotate 2.7272, like something like that. And we can change the outcome into a series. So to set that, there is a function in set series, create the series. We're gonna start from 0, and this means the step. The step is 2.7. So we connect the R to the step and the account. For now, it's 10, but for us, we need 33. So we connect the L to the C. So you can see for the output, the result is from 0 to 87, something like that. And we can connect the S to the A. But before connecting that, we need to right-click the S to graph them. So actually, this is our outcome. So you can see when you change the sliders, it is rotating layer by layer. So in total, it's gonna rotate like 90 degrees, but you can slightly change that. So I'm gonna blend all the previous things. I can rename it as break number and put that slider in front. And I can also okay, I have already renamed that. So I put that here. So now we have the plane. So the next thing, we're gonna create our brake to put the brake onto our planes. So there is a function in the surface which is called center box. So the brake size of mine is 150, 50, and 20. Because we have already created 20, so I just gonna connect this 20 to the Z. Z means the height. This is the length, the width. So now you can see this is my brake. But some tricky things for this function. If you set 150 to the X, it will create 150 both sides. So actually the brake size is double. So we need to right click here to give expressions, which is X divided by 2. Also, Y is X divided by 2. And the Z is x divided by 2. So now we have our break. And we need a function in the transform here, which is called orient. They will ask you the geometry that you want to put. The geometry is our break we have already created here. So we connect the B with the G. And the reference. The reference is the x is the 0, 0, 0 plane. So we're gonna connect this plane to the A. And the target are these. So we connect the G to the B. So for now, you can see the break they have already grown on our column. But it is not the same as mine because mine has some gap, but for now they are all overlapping one by one, so which is not perfect. So the method for me to do now is to get the 0 layer 2, 4, 6, 8, 10, and blah, 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 as one group. And layer 1, 3, 5, 7, 9, 11 as the other group. So let's do that. There is a function in the I think it's in the in the set, which is called flip matrix. So select that, connect the flip matrix here, and there is another function which is called dispatch. So connect the D with the L. They will give you 2 groups output. So we can preview that by using a geometry component. So connect the geometry with A, connect that geometry with B. So actually you can see we have already grouped them into 2 groups. The thing is that we just need to rotate this one to make the break in the middle of this. So I'm gonna use a function in the transform which is called rotate. Rotate this break, and we can set a rotation. Right click at the A, change that to degrees, and we're gonna set it to 60. So you can actually see this is the break after rotation, and this is the other group. So I just gonna show, I will blend all of the previous things so you can see that clearly. Yes, so this is our break. This one and that one. So I can rename it as gap rotation, which means that you can play with the gap rotation. So I'm gonna do that slider, put that slider in front. So we have like this kind of slider for you to play with in the AI environment. To preview the outcome, we need a function called merge. So we connect the geometry together. I just blend all of them. And I use the function in program which we learned in the previous session. And it is called sync object connected here. So now you can see your object in the AI environment. So I'm gonna show you how to modify that through the AI environment, which is the process that you're gonna record for your submission. So actually you don't need to know all the process. I just explained the logic for me to generate the column. But from now you need to pay attention to know what kind of things you're gonna play with for the submission. So I will show you from my mobile screen. Let me connect the mobile, connect my mobile phone.
For the submission, we just take the files that you downloaded and play with them.
Yeah, just play with that. I'm gonna show you what kind of things you can play now. Yeah. I know like this kind of things is quite difficult for you. So actually, if you don't have any experiments of using Grasshopper, you don't need to know how to do that. You just need to play with these interactive sliders in AR, and that's it. Where is my second? Sorry, I think my software crashed. I have to open that again, run that again. Yes, for now, I will show you. I will delete that. Okay, so this is the thing you're gonna see from my file if you drag the file into your Grasshopper. So you're gonna see something like that, and you can activate the photogram. Scan the QR. Maybe I'm gonna place my brick structure on the ground. Yes, so for now you can see the structure is here. Yes, and the function is called sync object. Sync parameters. So which for us to get this kind of sliders into our mobile phone. So I'm gonna choose column height and also middle zoom scale and also column rotation. So for now, when you click the left-hand side button, you will see the 3 operation sliders. So you can just play with the height, play with the middle zoom scale.
Sorry, that one is not working on my phone, and it's giving me a message. It says to add parameter to this panel, create a synchronized parameter component in Grasshopper and click the hologram icon next to any slider.
Yes, because I think you haven't connected that. Please try if this one has already been connected in Grasshopper.
This one?
Yes, this one. You can find it in Grasshopper in the hologram and here, which is called sync parameters. Click that, you will see the button like that, and click the one you're gonna input into your mobile phone.
Oh.
Just click here to light it up. So you can select like 3 sliders.
Okay, thank you.
So when you for your submission, you can just use your screen recording. Oh, sorry, because I'm stream my screen, so I cannot record. But for you, you can record that. So just record your screen to show like you can play with the sliders. Yes, to modify your design, and also you can like walking around with your design to see it 360 degree, or also you can see that from the top and go through something like that. If you want to do some more fancy video, you can change the colors as well. And also you can add the textures. So that's all you're gonna submit, just for playing with the interactive sliders and change some colors or add some textures.
In the document, it's synced, right?
Mm-hmm. In the document, what? Sorry.
It has this one, the sync button.
Yeah, in the document it has.
Okay.
Yeah. So the only thing you need to do is just let up. For example, I have already created several sliders. You just need to click the icon here. But now you can see if I click the column hat, you will see a column hat slider on your mobile phone. If I click column rotation, you will see another. If I click middle zoom scale, you will see the third. So for the free version, you can only add 3 parameters. So just choose 3 from my settings. So you can play with them. And remember to record this video. And you can also take some pictures with your structure, like that, something like that. You can also take some pictures. This is for the Grasshopper beginners. So if you want to do something more interesting, I'm gonna show you, but you don't need to do that. If you are very familiar with Grasshopper, you are very welcome to develop your own structure. So for example, I'm gonna show you something more interesting. So let me stop my screen, mobile screen. So if you have my file, just press and drag that into the Grasshopper. So you can actually see this is the file that I'm sharing to you, and you can play with that. And also, if you use this function, you can create something more fancy. So for example, I'm gonna create some other break. Maybe I can draw a sphere here.
Sorry, Doctor?
Yes.
When I drag the file, they ask me to install something
Install
that
what?
didn't appear. Can I show you?
Yeah. Let me stop sharing.
I'm gonna turn my video, my camera on. So that's the problem.
Install let me check, mesh area. Okay, it's all right. You can ignore that.
Okay, but no, the model doesn't appear.
Let me see what happened. You can press close and okay, I know. I'm gonna share my screen, so
okay,
you can follow that. If that happens, means you are missing this function. So you can go to the mesh, choose this one, mesh area.
Okay.
Can you find this component?
Okay, thank you.
Yeah, if you can
What
find
if
it.
we can't find mesh area?
I
I can't find it on my lap.
You can't find that.
No.
Or you can choose this one, mesh volume.
May I show you my screen?
Yeah, yeah.
Is it shown up?
Yeah, yeah, I can see your screen.
Okay. Can you see now?
Yeah, there is a white component which is the missing one.
Yes.
Yeah.
But I can't find I can't find here
the mesh. Let me check. You can double click at the empty place. Just double click. Not here. Yeah.
Yeah.
Tap mesh.
Okay.
Check. 1 second. Tap mesh area if you can find it. MESHAREA.
Yes, I can find it.
Mesh area. So there's no mesh area in your Grasshopper.
Yeah.
Yeah, there is. So just click that.
Okay.
Yeah, to replace connect the G with G and connect the C with the C. So for now, you will be able to see that because the version of the Grasshopper, there's some little problem about that.
Oh, okay. Thank you.
That's right. So everyone, if you meet this kind of problem, just find mesh area to replace that component. So you will be able to see my file. Yeah, for now, I'm gonna show you something interesting based on my file. So actually, I can let me delete this. Actually, I can find I can create a sphere here, and maybe let me create something else. Maybe a cone. And maybe a box. Yeah, it won't be beautiful, but I just want to show you what you can do. So you can enable this kind of component and right-click at the geometry. Choose Set Multiple Geometry. Select the box, the sphere. Oh, I'm sorry. You have to select the ball, the box, this box, and the cone together, and right-click Set Multiple Geometry. So they will be shown here. And you can get your geometries and also the reference plane. So to blend all of them, this is the reference plane and this is the geometry. So connect this geometry instead of my box. Connect this reference plane instead of my plane. Okay, so you're gonna see something or something gonna happen here. You need to activate this group. and connect the R to the G. So for now, you can see let me delete this. So for now, you can see a more interesting design. So you can play with the design instead of by using your own component. And also, you can try to color them into group. For example, I'm gonna delete that. There is a function in the sets, which is called list item. So connect the L with O. Double click here, choose 0, which means the 0 group, which is the basic break. So we can go to the hologram sync object. We can color it as red. And copy this. We're gonna double click as 1, which means the first group of the geometry. So you can see this group is the which one is the sphere. So I can color the sphere as blue. And copy and paste. Double click input 2, which means the second group is my cone. So I can set the cone as maybe yellow. Copy and paste. Input 3, which is my short breaks. I can color it as maybe purple. So you can do like more interesting design if you are using your own geometry. So just remember to group your geometry before you put the geometry here, and ungroup your geometry after you got the result. So after you ungroup, you can change, you can choose like the first geometry, second geometry, third and fourth geometry, and color them into different colors. So this is something interesting that you can play with. If you have any advanced Grasshopper knowledge, you can do that and have a recording for that. If not, you can just do the basic things based on my file to play with the interactive parameter sliders to change the column height.
The basic things, do we have to record also?
Sorry?
If we do just the basic things, do we have to record?
Yes, you need to record from your mobile phone, like showing you adjusting the parameter sliders to change the design, and you can also change the texture or colors.
Okay, thank you.
Yeah, if you want to do the basic. If you want to do something interesting, you can use this component, or you can create your own design structure. So now I think it is what time is it? 1 o'clock. So I will give you like half an hour for the lunch break, and you can develop your own design or just play with my design. And we're gonna meet again at 1:30. So from 1:30 to 2, I'm gonna answer like questions. If you have any questions, you can ask me during that time. And also you can show me your design or something. So see you in 30 minutes. but I will be online. So if you have any question, just give me a shout. Yeah, I'm back. Do you have any questions about the design or about anything?
Yes, I have a question.
Yeah, please.
I can import any file to Rhino program. I mean 3D Max or Revit CAD, Revit file.
You cannot import my file into Grasshopper, you mean?
Yes.
Can you share your screen? Because I don't know what happened.
No, I'm asking generally. I'm not doing that now. I'm asking if I can import any file from these programs.
I think you can import that successfully because I haven't met this kind of issue. You just need to open the Rhino and open the Grasshopper and drag my file to Grasshopper. And that's it. Very easy, simple.
Okay, great.
Yeah. And if you can't, you can just follow the recording. Yeah.
Yes.
Yes, I'm gonna just demonstrate one more time so you can get familiar with the whole workflow. And I'm gonna explain like what you're gonna submit because it is very important. If you don't upload your outcome, you won't get the workshop certifications. So please make sure that you have upload your workshop outcome before the end of tomorrow. So you will have a whole day, 1 day and a half to do that. I think is enough. So I'm gonna demonstrate again, how can you open my file and how can you play with that in AR. So from now, just remember, I'm gonna share my screen. So open Rhino. It will take a little bit of time because I have many plugins in Grasshopper. So yeah, just wait a little bit.
Excuse me, when will you download the recordings?
I think the conference will send you the recording soon, but I'm not sure what time you can get that. But I will demonstrate it now. So if you don't want to wait for the recording, you can record that by yourself. So this is all the things you need to submit. For example, when you open Rhino, here is Grasshopper, and click that, launch the Grasshopper, and download my file. I think you have already got the link from my previous email. So just click that link. You will see two files. The file you need to download is the second one, this one. So after you download the file, it is called Design Algorithm plus AR UI. So just click and drag that into Grasshopper. So you will see actually the design. And some students, they have questions before, they are missing this kind of component. So if the component here is white, you can just double click here to import mesh area. So you will find the component here. Click here, connect the M with the G, connect the C with that C. So that's it. This is the only problem related to the version of Grasshopper. So if you are missing this component, just double click here, input mesh area to find this component and connect the G to the M, connect the C to that C. If you don't have that problem, it should be all fine for you to play with. So to activate that in AR, I'm gonna share my mobile screen. Yes, this is my mobile screen. And I'm gonna put the physical, like something like here, so you can see everything clearly. Before you do that, just close the photogram. I think I have already closed that. So, okay, photogram. Press here to generate the QR code. Okay, my another Rhino is in the photogram. So remember, when you try to activate the photogram, just open one Rhino. So you have the QR code, scan the QR code from your phone, and you will see the hexagon, which is detecting the surface. Maybe you can scan on the floor and just tap the screen to select that surface. So now your column is on the ground. And in Grasshopper, you have like 1, 2, 3, 4, 5, 6, 7, 8. You have 8 choice for you to play with, but you can only select 3. So for example, if you select the column height, middle zoom scale, and the column rotation, you can check that on the left-hand side corner. Just press that. There will be the 3 sliders. So for now, you need to record the video for you to play with the parameter sliders. To have real-time modification in AR. So this is the thing that you need to submit. Just a video record for you to video recording for you to play with the parameter sliders. And also you can change other parameter sliders. So don't play with the same 3 as mine. Otherwise all the outcome will be the same. So actually you can change maybe the height of the brick. So now you can see the design is totally different. And you can change like column radius, and you can also add the brick number. For now is 3 bricks each layer, so maybe you can change that to 4 or 5. So just play with that, and maybe increase the length and increase the height. So there's so many things that you can play with. For now, if you think the height is reaching to the limitation because now it's already 1,000, so you can double click here, increase the maximum range. Maybe you can increase that to 2,000, and which means it's gonna be reached to 2 meters. The same method, you can double click at the name of the sliders in Grasshopper to change the minimum and maximum range. So you will have more freedom for design. Yes, you can just give a recording for that, like changing the parameters. And if you want to do more things, you can change the color, the texture to make it more unique or beautiful. Yes, so actually you can see something like very interesting. And also you can move your column. So just press the right-hand side corner. There will be a small square on your mobile phone. Press that, you will see a network. And just press your column and move. And you can use 2 fingers to scale it up or scale it down. Maybe you can place your design like somewhere nicely and take a photo of that. If you want to take a photo, just press the circle in the middle. So you can take a photo. Yeah, just try to play with that in AR. So first thing is to change the design, have a recording about change the design parameters. and change the colors or textures. And you can also press the right-hand side button to move that and scale it up and down. To confirm your location, just press the right-hand side corner again. So it will be locked here. You cannot move that again. If you want to move that again, you just press it again and move. Yeah. So I think it's quite easy for you. Just play with the parameter, change the color or add some texture pictures and move it to a nice place, have some photos with that. I think that's all. So if you don't have your own design, you can use my design. Just upload the recording video in AR. If you have your own design, you can also upload your own design to the file folder. So you are welcome to create your own design, but if you can't do that in Grasshopper, just upload some video and some nice pictures about you are playing with that in AR. I think that's all. So remember to upload that to the share folder. I will send that link again, but I think we already have some folders here. Just remember, use your full name as the folder name. And please check, don't create your folder in the other participants. Otherwise, I cannot see you here. So just create a folder here with your full name and upload the AR recording videos and some nice pictures to your folder if you don't have design. If you have design, please upload the Grasshopper design file as well. So are you like clearly what you're going to submit, or do you have any other questions about the whole process?
All is clear.
Yeah, I think it's quite clear. So yes, you have the file and you have your device. Just play with them, have some video recording and nice pictures. But you can change the range. Remember to change the range to make the design a little bit different as mine. Otherwise, I think the outcome from everybody gonna be the same. So you can play with them. Even it is not structure reasonable, but it's a kind of design. So you don't need to think about any physical constraint. You can just show an outcome like that. I think it's kind of interesting. So just be playful with these kind of sliders. Try to create something interesting. Yeah, and remember to upload your outcome at the end of tomorrow. Okay, I saw someone raise up the hands. Do you have any questions?
Yes, you showed us an example of someone of a project that applied physics to the bricks. Was that like a plugin in Rhino, or did you like use a third-party program, or?
You mean the case study I showed at the beginning?
Yeah, like the bricks falling down, and then you knew where to like.
Brick falling down.
Yeah.
So that is another plugin which is called. Let me check.
I think I've heard of it, but I don't think it's
called Physics X.
Yeah.
Physics SX. So you can get this plugin in for Rhino. So I can show you that. They have some basic example file and tutorial, so you can download that and try to use that. You can find that on food for Rhino. Food for Rhino and search PHYS. Oh no, and PHYSX. Yeah, it's here. It's a penguin. So they have the tutorial and the example file you can download and try. So it is a simulation for the structure stability performance. Yeah. So you can simulate your structure can be stand or not. And you can also connect that output with hologram. So you can see the structure stability in
Obviously, yeah.
Yes.
Thank you.
Yeah, you're welcome. And any other questions?
Could you please copy and paste the link you now opened?
For the simulation, you mean?
Yeah.
Okay, I will copy and paste that to our chat. Oh, sorry, I think I sent everybody. Yes.
I'd like to ask like a personal question, like what made you interested in the use of AR and, you know, like cyber physical construction and all that from the first place?
I think at the beginning, like this is a kind of very new technology devices. So I think I have tried some VR immersive game, and I think that could has the possibility to benefit for the architectural design. So like normally we just sit here to design something on the computer screen, and I think we lost the scale. Even we have some 3D modeling or some rendering, we cannot access that personally. So I think AR gives us very good experiments for you to feel your design in a real scale in the physical world. So maybe you cannot feel that obviously from your mobile device, but if you have any chance to get an AR headset, you will feel that totally in a different world. So it is kind of cool, I think. And I think the AR devices, they are like quite expensive. It's around 3,000 pounds, but you can also try some VR devices to try your design. And I think the hologram gives you a very great opportunity. So maybe in the future, if you want to show your design to your tutor or show your design to someone else, you can just import all the geometry and use the function that I told you, like use the sync object. You can create the color, create the texture of your model, and try that in the real physical world with the correct scale. So I think it is a very interesting tool for both architecture design and both like immersive experiments. So that's why I'm really interested in that.
Cool, thank you.
Thank you.
Can I ask a question, please?
Yeah, please.
I saw in those videos about the introduction of the artworks, the teamworks are wearing kind of black goggles. Are there VR goggles or it's just protection like glass?
Yeah, they're
Let me check. You mean the goggles like that?
no, he means the HoloLens, I think.
Yeah.
That is the HoloLens, the AR headset.
Oh yeah, this is different than the Oculus 2, or this is similar?
It's different. It's called HoloLens. So you can Google that via Microsoft website. So they will give you a basic like introduction, like what it gonna do. So this headset is totally different with the virtual reality, because in the virtual reality you cannot see the real world up on your virtual model. But this one is a transparent goggle, so you can see virtual environments and also the virtual models and also the physical environment. So they are overlapping with each other together.
Okay, thank you.
Yeah, but this device is much more expensive than the VR headset.
Yeah, they have gears or something else than the headset, or just the part of the head. They're like the hand gears. I saw he's wearing kind of something on like a glove or something on his wrist.
They have, but they can achieve all the functions only on the headset. Yeah, so for the HoloLens second generation, it actually can read your hands. So when you show your hands, it will transform your hands into a virtual model. And you can do like a twisting or rotating or something more interesting in the headset.
Yes, thank you.
Yeah, I think for today's tutorial, it is a kind of experiment for you to try AR in a cheap and easy way, because we only have our mobile phone. But if you are really interested in that, you can try the AR headset. Yeah, and this is something you're gonna see from the headset. I have tried a second generation. It feels really smooth and good. And you can see some virtual characters, and you can like play with the characters and play with your models only by your hand gestures, because it can read your hand gestures. Yes, I think you can submit all your files till the end of tomorrow. So you will have 1.5 days to do that, which I think it is pretty enough time for you to just do some slider modifications and the video recording or some nice pictures. Yeah, I think.
Thank you so much.
Yeah, if you don't have any other questions, I think we are approaching to the end of the workshop. So if you have any other questions about like augmented reality or about robotic fabrication, you can just email me. I think you all have my email. And you can also follow me on Instagram via design.studio. So I will upload like my new research outcomes or some AR videos on that account. So thank you for you to join the workshop today, and I hope you have enjoyed that and learned something as a beginner for the AR.
Yes, it was very interesting. Thank you.
Thank you. Just remember to see the outcomes. Thank you.
Thank you.
See you.
Thank you, doctor.
See you. Bye.